All right, so we're going to talk about the tabular method. So first we're going to try it the normal way. So we're going to call this u, and this one's our dv, because again we always want to pick the algebraic first. So u equals, well, in this problem we want to pick the algebraic first. dv equals e to the x dx. So our du equals 5x to the 4th dx, and our v equals e to the x. So now you may notice that this didn't get rid of anything. It made it nicer, but we still have an integral that when we put them together, that is still something we need to work with. So we do it again. I'm going to do this one in green. So this is our u. This is our dv. So our u equals 5x to the 4th. dv equals e to the x. And the reason we're doing this is I want you to see the pattern. And then we will look at the tabular method. So yeah, you could fast forward, but I recommend staying here because you want to see the pattern on how things work. So this is going to give us those two together. 5x to the, that's not first, there's nothing there. 5x to the 4th, e to the x, minus integral, and then those two together. So 20x cubed e to the x dx. So you may notice that it's changing. Now when I bring down this minus, you're going to get a minus here and a plus here. Signs change. And then we bring this one down. In fact, what we're going to do is just put a little arrow at the end. But now our integral there, we're going to go into black now. And we're going to do that one. Well, that's way too, let's make it smaller. There we go. So this will become our u. This is our dv. Hopefully you're seeing the pattern here, that we can just keep doing this over and over again. So you don't have to use the tabular method if you don't want to. You can just do brute force. So du equals 60x squared. V equals e to the x. And so we get 20x cubed e to the x minus the integral of 60x squared e to the x dx. And then now we're going to go back to blue. So that's still a plus. It would be plus and plus. Everything works out. So what I'm going to do now is rewrite it and then continue off to the other side. So we have x to the 5th e to the x minus 5x to the 4th e to the x plus, and then we get 20x cubed e to the x minus the integral of 60x squared e to the x dx. And then we're going to take this, because I told you this is the long method, and move it over here. And then we're going to shrink it, and we're going to continue on. All right. So now our first u would be that 60x squared. Our dv is equal to e to the x. So du equals 120x. V equals e to the x. I forgot the dx there. And there's a dx there. Did I forget the dx? Yeah, I forgot the dx on all of them. So dx. This is why this method can get tiring. I got the dx there. Okay, so got all the dx's. Okay, now we continue on. So this is 60x squared e to the x minus the integral of these two on the bottom. So 120x e to the x. So we're almost there. So the last one now. Now, there's a minus in front, so that becomes minus and plus. Remember, wherever there's a minus, that negative will get distributed, so we want to change those signs. So instead of doing plus minus, we do minus plus. All right. Now u equals 120x dv. See, I want to put du all the time. Equals e to the x dx. Yep. And so our v equals e to the x. Our du equals 120, and see, now the x is gone. So now when we write it, it's 120x e to the x minus the integral of those two together. So 120 e to the x dx. And then that's a nice quick one. It's just minus 120 e to the x. There's a plus in front, so we got that, plus 120 x e to the x, and you can already see, my lord, right? So what we want here is a pattern, because this is not fun. So it's x to the 5th e to the, and math should be fun, minus 5x to the 4th e to the x plus 20x cubed e to the x. So maybe it was a little fun to do it, but anyways, we're back to here, minus 60x squared e to the x plus 120x, and you can make sure you didn't miss any because it just descends. So you can see that all the way through. And then we should factor out that e to the x, but we end up with this. X to the 5th minus 5x to the 4th plus 20x cubed minus 60x squared plus 120x minus 120. And there you have it. So let's look for some patterns here. Number one, they all have the e to the x, except for that one. And we forgot the plus c. There we go. And then over here, the signs, it's positive, minus, positive, minus, positive, minus, right? And each of these is just the derivative of it. So it's the derivative of that is this, the derivative of that one goes here, and the derivative of that one goes here, and the derivative of that one goes here, and the derivative of that one goes here. And the other one is just the integral of itself. So if we use this, the reason they call it a tabular is we're going to make a table. So we're going to call the first one u. We're going to do the exact same problem, but this time the tabular. You can see I have less room here. So we start with our x to the 5, and then we put here our e to the x dx. And what we're going to do is take the derivative of this one all the way down, because that's all we did on that previous problem. That was it, right? You can see it. Look at our u. It's just derivative, and then we reapply it, and derivative, and then we reapply it, and then derivative, and then we reapply it, and derivative, and then we're finally done, right? But that's all we did, so we take it here. And then on the other side is just this one, and we integrate it all the way down. So this would just become e to the x, e to the x, e to the x. Every single time it's e to the x, e to the x. Because remember, whatever you had gotten there would have ended up in the second part anyways, and you would just integrate it, and then integrate it, and then integrate it, and integrate it. So they stay on their own side all the way down. And now, we already know there's a dx here, but what I like to do is instead of putting it there, we put it here. Now, the reason is we're going to take this now, and it's supposed to be a quicker method, so it's supposed to show us what we're doing. So the first one, right, when we do this, it's just going to be these two multiplied, just like that. So it would be x to the 5th, e to the x. That's our first one, right? And then we would make a new integral, and it would be the next two. But the next two, if you notice, came from the minus, and so it changed the sign. So you can see it was positive here, the next one's negative. So we're going to put a little red line there to represent a negative, and we put a negative on there. And then that becomes minus 5x to the 4th e to the x. You guys see how this is working? All right, let's shrink this a bit. And then the next one was positive because they alternate. And we get 20x cubed e to the x. So you can kind of see the pattern that's happening here. Minus, and then plus, and then the last one's minus. So we end up with just writing them. That's it. So once you have the table, you can just write it. So it's minus 60x squared e to the x plus 120x e to the x minus, and then it's 120 e to the x dx, our integral. And that's our last one. So the last one is our integral that we need to finish, but we know we're done because it's nice. So you kept going until you get that 120. And then the integral of that is minus 120 e to the x plus c. And you can see it's the exact same problem. So we end up with e to the x, and then it's x to the 5th minus 5x to the 4th plus 20x cubed minus 60x squared plus 120x minus 120 plus c. See? Exact same one. So the ending one is your integral, and it's just basically this process. So the reason you want to do it a few times longhand is it gets you that idea. So at the very end, you get the 120 e to the x right there. And then you integrate it. And that's why I said to leave the dx. And so that last one is your integral of those two multiplied together. There you go. Tabular. In the next video, we'll do some more examples, some more complicated ones.